Yeah, so today I'm going to present about function. This is a reflection of my journey of learning functional programming as a Rubyist, and I just want to share my story about how to apply like functional programming in Ruby and what we can gain back from this functional concept. Before that, credit, I'm myself still a beginner in learning functional programming, so this is just my story, my experience. So here goes the story. Anyone here goes to Melbourne RubyConf this year? Cool. So as a Rubyist, I love going to RubyConf. It's amazing. But this year, RubyConf, there's some Elixir talk in the middle of RubyConf. It's great. I love it. But what I'm trying to show is that there seems to be a buzz of functional programming, and as a Ruby community, we are actually heading towards functional and people looking to Elixir. And then as a Rubyist, I also went to other conferences. I went to Lambda Jam, YaoConf, and Ruby Meetup, and I've seen people have started to be talking more about functional programming, like the language you can see there, Haskell, Scala, Clojure, Elixir. So looking at all these recent buzz, it kind of prompts me about the journey. Okay, all this buzz about functional programming, cool. I'm drinking the Kool-Aid. I'm jumping into the wagon and go and venture into the journey about learning Haskell, Elixir, and Clojure. So before telling more about my story of functional programming, what is functional programming in the first place? When I Google Wikipedia, it says that it's a style of building a structure and elements of computer programs that treats computation as the evaluation of mathematical functions, and the key points is it avoids changing state and mutable data. Okay, that's cool. What else? Talking to a lot of functional guru monks, they're telling me, oh, functional programming is about higher order functions, currying, composition, immutability, and they even show me a picture of Fortran. So I was like, oh, that sounds pretty cool. I'm in. So while I was in the journey of learning functional programming, there's a key question that keeps coming to my mind. Why do I what's the buzz about this functional programming? Why do I care about this thing? So looking at my day-to-day job and also just in general, I'm not saying to everyone, but just in general, most of software dev, the thing we're doing, we're just building things that handling requests, fetch data from database, do some computation and return a response. In a summary, it's just mostly a request-response lifecycle. To me, I'm a visual person, and this is how I visualize what happened when we build a web application. You have a request that comes in and goes to control all the way, and then you get a response back. And then at work, one day I've seen this kind of code. For example, I have a code a client that go and fetch something, let's say from Facebook, and then it rescue an error and then raise another exception. And I have another code in here that then it needs to log the error message. So it rescue the error and then log another error messages. And I have an application controller in here that will then rescue the exception and then render the for page. My brain is quite small. I'm not as smart as most people. And to me, when I try to visualize this, it looks like this. There's just things firing events to it. When I try to follow the stack trace, it jumped to exception and then somewhere else rescuing it and then raise another exception. If I get woken up in the middle of the night trying to debug this, where do I even begin with? And my reaction to this kind of code is flipping the table. This is insanity. My brain is too small to process this. So to me, why functional programming is because a lot of times, to me at work, a lot of times I spend actually reading the code rather than writing the code. Writing the code is in fact the easiest part of the job. It's more about understanding the code that I read and then think about the problem and then write the solution. Cool. So now that, like, at this point, I'm kind of convinced, okay, functional programming maybe is the solution that we need in software world. So how do we apply functional programming? So being enthusiastic about my learning about the what and why of functional programming, I go back to work and convince the teams, let's use functional programming. However, people have different opinions about functional programming. I've got people who like, okay, let's use Haskell, let's use Scala, let's use Clojure, let's use Elixir. And this debate goes for a while. In the end, we couldn't come with any decision. Okay, like we want to do functional programming, but we couldn't even decide a language to use. And then there's a light bulb moment that, you know, like pops onto my mind. It's like, hey, hang on, Ruby actually can write, like can do functional programming. So let's actually apply the concept we learned from other languages and bring it to Ruby, so that as a Rubyist, we can write a code that, you know, make us happy. Like Ruby was designed to make programming happy, right? But let's make it, you know, so that we can even write a happier code. So in this talk, I want to show you that, yes, you can actually do functional programming with Ruby. So my first question before I go into like talking about, you know, we talk about functional programming. Yes, there's a function, but do anyone here know the difference between a function and a method? Yep. Yep. Sorry? Yes, this kind of like, yeah, so a method is something that, so a method is actually bounded to an object, whereas a function is just a pure function where you just have input and output, but a method is actually bounded to an object. So kind of in that direction. So the part that I want to show you is that we actually can use, like in Ruby it's so common that we actually write method, but sometimes we forgot that we actually can use Ruby to write a function, which is not actually bounded to any context. So I'm going to show you some proof that we actually can use Ruby to do any of this functional programming stuff. Sorry, let me see if the screen is big enough. Cool, all right. I hope this won't go wrong because love coding normally always ends up bad. Cool, all right. So that's my cheat sheet. But before that, I want to quickly show that you, like the one way to write a function in Ruby, for example, let's say I'm writing a function that adds 1. One way is you actually can, Ruby provide things called lambda that you can do that takes, taking an argument and you can do something like this. And then if I say add 1, and let's say if I use call with, let's say 3, I get 4. Cool. So actually Ruby does give you lambda. There's also a cousin to lambda, it's called prop, but lambda is better for different reasons, which I'm not going to cover here. But you might be thinking, hey, this is a bit too verbose in writing a function in Ruby. You can write another way. You can write it like, okay, in this shorter syntax. And it still works, and you still get it. Oops. So the point what I'm trying to show is that, like, you can use lambda to write a function in Ruby, and there's actually various ways to write it. Like, there's one which is this way, the one I've shown above. Another one is which is this way. And this is a shorthand, which is what I'm going to refer to from this point, that this is like a shortcut way to define lambda. Oops, I deleted it. And also to call the function, there's also a couple of ways. First one is I can just add 1.call 9, for example, let's say call 10, get 11. And same thing here, this is just another shorthand to call a lambda. Instead of .call, I just dot with a bracket. Or I can use a square bracket. So, whoops, trying to find this. So now that we know that Ruby can actually write a function, Ruby can also write a higher order functions. So what's a higher order function? Higher order function is a function that can take an input or argument or a function as argument, and it also can return a value or a function. I'll show you what it means. So, oops. So for example, in here, like, let me close this one first. So if you've seen, for example, other languages like Clojure or JavaScript, that's like a map function. A map function is something that takes a function and a collection, and what it does is it will apply a function to its collection. For example, if I take a map of function at 1, and I take an array of 1, 2, and 3, I will get 2, 3, and 4. And we actually can do that in Ruby as well. Oops. So if I will show the longer syntax, this is how you define a map function. You take a lambda, take a function and collection, and then you map the collection and apply the function individually. And if I'm gonna shortcut the syntax to a shorter version to those who are not familiar, this is how you write it. You can collection.map, and the ampersand here is just a shortcut to convert a symbol to a function. And this might sound like a bit crazy, but this is another way of writing the map function. A map function is a function that takes a function as an argument and a collection, and you apply a function to each of these collection. And then to prove that it's working, I can just, like, say, put in this 10, 11, and 12, and I get 11, 12, and 13. Cool. So I've proved that, oops, open this again, that Ruby can actually write function and also higher order functions. But Ruby also can do partial applications, or what you call currying. And what it means is that you can partially apply a function and you can and fully evaluate later. So example in here, if I have a map function that takes a function as an input and a collection as a second argument, and I can apply the things, and now I define another function. Let's say this one is just a lambda or probably the same. So I have a function called adder that takes argument x and y, and it's just going to add x and y. And Ruby actually provide a method called carry that you can call, which will automatically make this proc or function carryable. So for example, if I define add1 with adder.carry1, I actually return a proc itself, or lambda in this case. And what's really cool about this means that I can define a function and I can partially apply it to a certain context, and I can reuse that for multiple times. For example, I can just use a map function on add1 and apply it to collection, and add1 is just adder, which is just being carried with an argument 1. And similar, if I want to, okay, business requirement come and say that now I need to use add2. All I need to do, I just use the same function, adder, carry it, and call it with argument 2. And now I can just map add2, and it will just add 2 on this collection. Oops. Cool. So I've proven that Ruby actually can do functions, higher order functions, and also carrying. But to me, the coolest thing that you can do with function in Ruby is actually function composition. And what function composition means is that you can kind of like combine multiple functions to build a bigger functions that can do more powerful things. And actually, if I show my browser in here, no, I get it from this. Actually, there's in a Ruby bug issue, there's actually there's been discussion to actually add a composition for props so that we can support it natively. But in general consensus, people do agree that we need that. But for 5 years, we've been debating on what kind of syntax to use. So currently, unfortunately, it's still not there natively yet because people are still kind of debating on what to use. But based on the one that Matsumoto gave the thumbs up is actually using this syntax. Using a plus to do a forward composition and using the asterisk to do a backward composition. And what is forward and backward? So to give an example, let's say I define a function called multiply 2 that takes an input and multiply by 2. I define a function multiply 3 that takes input and multiply by 3. Another function add 1 that takes an input and add 1. And a backward composition will then, you can put all these functions together and it will evaluate from the right and evaluate to the left. So for example, in this case, it will evaluate an input. For example, if I put 5, it will 5 plus 1 and then multiply by 3 and multiply by 2. And with forward composition, what it does is actually from left to the right. Cool. So this sounds pretty interesting, but what can I do with this? So in typical web application, when you have a request come in, it's very common that we want to pass the params that's coming, for example, and you want to do certain operation to it. So let's say, for example, what I want to do is I want to strip the string and I want to add header and I want a pen name. How do I do that? What you can do is you actually can write each function separately. I have a function that add header. What it does is take an input and add a header on it, like title. I can append name, and I have another function that strip words. If you're familiar with Elixir, generally in Elixir, you tend to look at code as a data pipelining. And the way I would imagine is a assembly line, and then you can put something at one end and you can see that it's being processed through multiple processors. In this case, you have input that goes through like a function strip word, capitalized, add header, and append name. And in this case, if I were to use a for composition, I can do something similar. I define a function called format as title. Take this multiple function called strip word, capitalized, add header, and append name. And let's say if I have a format title in here called Ruby meetup. And I can actually combine all these different functions to form one new function that actually can do all of this. And to me, this is actually really powerful. And in Ruby, when I learned about composition, to me, this is actually a very composable code because each code is modular and small and very easily testable. And you might say that to implement this, I need to monkey patch. And some of you might be like, holy shit, I don't want to do function programming in Ruby if I have to monkey patch. Fortunately, Sonic actually write this library called transprog that allows us to write compose procs into a functional pipeline. And this is highly inspired by Elixir F#. So to give you an example, let's say if I require transprog, and this is just the library. And if you look at the code, it's very similar. Add header with this function. I can do exactly the same way. Add header is a function that take a value, append it, likewise as append name, strip words, and also capitalize. And it also provides you with a symbol that can do a composition, and this is very similar to F#. And if I were to change hello Ruby, and it works. Oops, sorry, trying to go back here. Cool. So you might be thinking at this point, so what's the big deal? What's the why do I even care about all of this? Personally, for me, this is actually really useful if you actually let's say in web application, you have a request parameter coming in, Like, imagine if you write a code that you can easily composable and write tests to pass or transform these payloads into another things. For example, in this example, imagine if I have a payloads in this kind of format. And I can use transport, and transport actually also provide me with some additional helper to transform hash and array. And I can also import other function from Inflector gem to do caramelize, and I can also define my own function. And for example, in this case, I define function register, which then I can test this append by function. As you can see that if I change this to Mary, I get Marido. And also I can just like, for example, in this case, I'm just kind of like rename it to easier to read. And I can define a customer transformer that the function is very easily to reason, because I can see that customer transformers is just a function that apply a function that symbolize keys and then rename keys from username to user and then append it by user and door. And I can easily test this as well. And then I can then use this transformer and apply even to another function. In this case, I have a customer's transformers that process this payload of multiple customers. And I'm actually applying a map array with this function, which then applied to this function to wrap the city, street, and zip code into this. And in real world scenario, for example, I have a customer model that can create a customer based on payload and have a service object. And what I can do is I can just use this customer transformer and just transform the payload and then create a customer. And all of this code here is actually very composable and easily to test. Oops. For me, seeing this kind of code is kind of like, holy shit. Like I can write each of those series step of operation as a one thing. I can easily test it. I can just use it easily and carry with me. It's amazing. And then I think some of you in here might be like, hang on, what about side effects? In the earlier, I was mentioning about like my problems because of raising exception side effects. Unfortunately, that since this talk is only 20 minutes and I might actually be a bit over time, I decided not to cover side effects on this talk. And if anyone is interested to see how we cover side effects on this talk, I'm more than happy to come back for part 2 of this talk and talk about how we handle side effects and how do we handle things in day-to-day code more functional way. Thank you.
Why are you making me exercise?
Sorry, I'm sure you're going to talk about this in your part 2, but my biggest question is mutability.
Yes, to me, I want to tell this as much. I don't want to go down the FP philosophy of like, because I know I didn't cover mutability because I want to more cover of the pattern and style of function programming and how to use the library to our day-to-day work. So I intentionally not covering immutability just so that I can just show you the shape of the code when you write functionally.
Next month?
Thanks. Yeah.
Part 2. How have you found using it in production if you've actually gotten into production?
I find it's really good because I find the code is actually much easier to test and it's easier to reason. So if there's any issue in, let's say if I put a payload in and the things is maltransformed, it's very easy to find out where it is actually, which part of this pipeline is broken, because each thing is just a function on its own. It's very composable and it's very easily testable.
Have you convinced your team yet?
Sorry?
Have you convinced your team yet?
Oh yeah, so our team, a lot of us want to do FP, but we couldn't reach the consensus, but then I'll tell you saying, hey, the whole point about FP is actually not about the language. The language is just a tool. what's more important is how do you bring back the knowledge and benefit you gain from FP? Because to me personally, FP, that what it teaches me is how to handle how to encapsulate side effects. If you can write, like Gary Benhart gave a really good talk about boundaries, and what he's saying is about functional call and imperative shell. If you can write code that can clearly isolate the computation part in functional way, but the part that do side effect, and you can kind of push it away and maybe wrap in a like monolith container, perfect.
Yeah, I have a functional programming background, but I'm embarrassed to say I don't know what currying is. Can you tell me more about currying, please?
Okay. Firstly, sorry if my explanation is too fast when I cover currying part. So let me exit this. So currying is just like a way to partially apply a function. So for example, adder in here, right? It's a function that takes two arguments, x and y. But let's say, and then I want to reuse this function to a certain context. For example, I want to use this adder function that takes two arguments, but I want to apply just add one, right? So in this case, I'm actually doing a currying already because I'm partially applying this function adder to just add one. And then this add one, I can reuse it multiple times. And then if a business requirement change, say, oh, sorry, like I actually don't want to add one, I want to add 100. Easy to change, right? Because you get this function. All you need to do is just rewrite this to add 100, and you just do this. And then it actually return a proc, which then you can use it in your code. And all you do, to me, I think of this like a Lego block, then you just change one of the block. Cool. Hi.
So functional programming is great. I love it. And I love it for the same reasons that Gary Bernhardt loves it with the functional core imperative shell stuff. Did you look at things like the interactor pattern before you dove into doing functional programming in Ruby?
So which pattern?
Interactor?
No, not really.
I think it's something you might like.
Okay.
It's not quite this, but it's more OO than this, but it does allow you to chain together discrete pieces of functionality. And it's a similar outcome with a very different approach.
Okay.
So it's something interesting for people that might find this interesting, but maybe a bit too functional.
Yep. Cool. I'll check out
having a look.
Interactive pattern. I'll give like if I'm going to talk for part two, like the thing that I want to cover mostly, if you want to interested in the next talk, look up a gem library called Dry Transaction. So Dry Transaction is heavily inspired by Alexa and F#, which is talking about railway-oriented programming. If I quickly show you, how do I get out of this? So if I give you my first prototype of my slide, I just want to show you this. So in this is one of the pattern that in what dry transaction is actually wanting to apply in your code is that it's very like you have a pipeline of functions or operations, and you can easily like encapsulate your side effect things. Like let's say if there's failure, and how do you actually branch the code? And then based on this, it's easy to pattern matching on what's going wrong in here. Cool. So that's a sneak peek of what's my second talk about. Cool.
Hi, I've got a question here.
Yes.
And it's sort of related to the statement of interactor. Could you write or apply functional principles in object-oriented way? So if you could build a really strict Ruby object and it wouldn't mutate state and it only takes one input and spits out the output, is that possible? Have you done it?
Probably, I mean, like Ruby is a dynamic type. Like, I mean, you can enforce in a way, but if any member of your team want to kind of dig the other hole, there's nothing to stop you. But If you apply to a certain pattern, like for example, like what Gary Benhart was talking about in boundaries, like with functional call and imperative shell, it's actually like, like hard to do that. But having said that, I do understand what you mean, like with immutability constants in Ruby, because Ruby is hard to do that on hash object.
Any other questions?
Cool. Round of applause for Jaya, please.
Cool, thank you.